In today's video, I'm going to introduce you to an incredible software called snapraid. If you're looking to safeguard your precious data and add an extra layer of protection to your home server, then you're in the right place. Stick around as I'll guide you through the step-by-step process on ensuring that you can implement snapraid on your home server. What is snapraid and why do you need it? Let's start by understanding what snapraid is and why it's crucial for any home server enthusiast. Snapraid is an open source software solution that provides data protection by implementing a RAID-like system called parity RAID. It allows you to recover data even if multiple drives fail simultaneously, ensuring the integrity and availability of your files. This means that even if a drive fails, your data remains intact. Now, key features and benefits of snapraid. Snapraid offers several features that make it a standout choice for home server setups. Here are a few notable features and benefits. Its non-destructive nature. Snapraid operates in a non-destructive manner, meaning it doesn't strip your data across drives. Each drive can be accessed independently, making it easy to retrieve individual files. Scalability. With snapraid, you can easily expand your storage capacity by adding drives as needed without reconfiguring your entire system. You can use disks already filled with files without needing to reformat or reconfigure them. All your data is hashed to ensure data integrity and avoid corruption. If a failed disk are too many to recover, then you only lose the data of that disk. If you accidentally delete some files, you can recover them. The disk can be different sizes. It can be an 8 terabyte combined with a 4 terabyte combined with a 12 terabyte. So it's very flexible. It doesn't lock in your data. You can stop using snapraid at any point without needing to reformat, move data, or reconfigure anything. So what are the limitations of snapraid? Well, snapraid combines features of RAID and backup programs to provide optimal benefits. However, it has its limitations to consider. If a disk fails and you haven't recently synced, a complete recovery may not be possible. Specifically, you may not be able to recover files changed or deleted since the last sync, even if they're not on the failed disk. Snapraid is best for data that rarely changes. That's why it's perfect for a home server or like a media server. So here are a couple of other limitations. No real-time recovery. Snapraid does not support real-time recovery, meaning you may need to temporarily stop working when a disk fails, so that you can start the process of recovering that failed disk. Limited recovery. Snapraid can recover data only from a limited number of disks, whereas with a backup system, you can recover from a complete failure of the entire disk array. So if your entire disk array fails, let's say 8 or like half of your disks fails at the same time, you won't be able to recover data. That's why I suggest you always have a backup of all your data in another server, in another computer, or in an external drive. Limited data saved. Snapraid only saves file data, timestamps, symlinks, and hard links. Permissions, ownership, and extended attributes are not preserved. Despite these limitations, snapraid is a valuable option, particularly for data that changes very rarely. Before diving into the setup process, it's essential to plan your snapraid configuration. Determine the number of data and parity drives you'll need based on the storage requirements and the level of redundancy that you desire. We recommend having at least one parity drive for your array. This will be equivalent of a conventional RAID 5. If you want more protection, you can choose 2 parity drives. This will be the equivalent of RAID 6. Now it's time to roll up our sleeves and get into the setup process. We're going to go to our previous VM where we left off in the last video. So we have mergerfs already install and set up on that VM. This combination of mergerfs and snapraid is perfect for a home server. So let's dive in. First thing that we're going to do is we're going to connect with SSH to our VM. We put in the password. So let's look at our drives. For that, we're going to use lsblk command. All right, so we can see that we have 3 drives with 3 partitions here, 1, 2, and 3. It's important to know this because when we're going to set up the snapraid configuration, we're going to need the paths to these drives. We're going to clone the git repository of the author of snapraid. This is the command. Okay, as you can see, git is not installed on our VM, so let's go ahead and install git. We say yes to this. Since snapraid is not an application that is already compiled, we need to install some development tools on our VM so that we can compile and install snapraid. One of them is git, which we just installed. So the next one is a development tool group of packages. And to do that, we are going to use the following command. Okay, so we say yes to this. It's going to install compilers, libraries, and many other packages that we're going to need to be able to compile snapraid. Okay, so all of the packages are installed. Now let's try to clone again. Okay, perfect. So now if we list here, we can see that we have our snapraid folder. And to make life easier, I'm just going to paste the command that is going to do everything for you. This command will be in the description of the video. So I'll explain the command. We're going to cd or change directory into the snapraid folder. We're going to execute the autogen script to prepare the compilation. And then we're going to execute the configure command, which is going to configure all the settings for the compilation. Then we're going to execute the make command, which is actually going to go ahead and compile snapraid. And then we're going to use the make install command to actually install snapraid on our server. Okay, so it's going to run through everything that it needs. Now it's compiling. This might take a little bit longer depending on how powerful your server is, but this is a small VM with 4 cores, and as you can see, it was pretty fast to compile. So it looks like everything finished properly. Let's see if a snapraid is installed, and let's check the version just to make sure that everything is correctly installed. For that, we're going to type snapraid. As you can see, it's in my path already. That's a good sign. And then we're going to do version. And as you can see, snapraid is installed. Perfect. Let's clear our terminal now. Okay, so there's a couple of things that we need to set up before we can start using snapraid. The first thing that we need to set up is the configuration file. I like to put it just on the etc directory. It's just easy to find and easy to remember so that I don't have to dive into like many folders and try to find the configuration file. So we're going to create a new file called snapraid.conf. For that, we're going to use vim again. We're going to go to the etc directory. And we're going to call it snapraid.conf. All right. We hit I to insert new content. And I'm going to copy the configuration file that I already use on my production server. And I'm going to put this on the description of the video too, so that you can copy it and then use it as a template for your server at home. So let's dive into this configuration file. Okay. So the first section of the file, actually, let's save first, just as it is. Let's open it again. Okay, that's a better format. It looks better. Okay, so the first part is where we're going to configure our parity drives. As you can see here, I have 1-parity, 2-parity, meaning that in my production server, I have 2 parity drives. Now, so we have to give it the path to the mount point where our parity drive is mounted. So let's go and find that out first. Let's exit from here. And if we do the command df-h, okay, so we can see that our parity drive 1 is mounted into /mnt parity 1. So let's copy that path. Let's open a configuration file again. Since we're only going to have 1 parity, we're just going to delete the second one and we're going to replace the path here. I think it's very similar to my production server, so that's how you want the configuration file to look like for your parity. Basically, this snapraid.parity file is all the parity data of your array. So we're just telling, with this configuration file, we're telling, please store it into this drive. Now, remember that this drive is not part of your merger.fs array. So only this file, the snapraid.parity, should live in your parity drive. No other file should be there. So now the next thing that we need to do is we need to configure the snapraid.content file. So as you can see here, you can read the description of the configuration. It says, define the files to use as content list. You can use multiple specifications to store more copies. You must have at least 1 copy for each parity file plus 1. They can be in disk used for data parity or boot, but each file must be in a different disk. Format, content, file path. So basically, the snapraid.content file is the file that it's kind of like a database of all, where are all your files located. So this file is very important too, like the snapraid.parity file. So what I do is I usually choose allocation in my boot drive, and I also choose two other locations in random disks on my array. So this way I have like a triple failsafe. So if two drives, if disk 1 and disk 2 they both fail, and I lose the snapraid.content file, I'm gonna have a copy in my boot drive. And the same thing the other way around. If my boot drive fails, then, well, you're in more trouble, but you will also have a copy on your other drives. And since we're using mergerfs and snapraid, we have the ability to just take one drive out of the array, plug it into a USB converter, and we can actually read the file system and the files that are in there. So that's also very flexible and a great feature of snapraid and mergerfs. So for this, if we go back to our drives, let's save our configuration file. If we go back to our regular data drives, we have it here in /mount disk 1 and /mount mnt disk 2. So those two already match, but you would need to put the equivalent on your server. If you configure your mount points differently, you need to change the configuration file. So let's go back to the configuration file. And here we can see that /var snapraid.content, mnt disk 1, mnt disk 2. So for this example, we don't need to change anything, but you will have to change this if your mount points are different. So now the third part of the configuration file is you need to define your data disks. So here is where we are going to define your data disk. If you have 9 disks, like in my production server, you would have to put all 9 of them. For this example, we only have 2 drives. So we're only going to define the 2 drives that we have. We're going to erase all the drives and just leave disk 1 and disk 2. All right. Now, the third part of the configuration file is exclude hidden files and directories. If there are some files and directories on your array or your data disk that you would like to exclude from the parity calculation and from the protection that snapraid brings, here's where you would put those directories. In this case, I exclude the lost and found just because it's information that I don't need to be synced. This is the lost and found is a feature of the Linux file system XFS, and I don't really care about that data, so I just exclude it. So with this now, we have good configuration file. We configured our parity, we configured our content files, and we configured our 2 disks that we have. And we also excluded some files and folders that we don't really care about syncing or protecting. All right, so let's save this. So with the configuration file set, now we can start using snapraid. So the first thing that we need to do is to make sure that our configuration file is good. And to do that, we're going to do a sync with empty drives. To do that, we're going to type the command snapraid sync. So if we analyze the output a little bit, we can see that there's a couple of warnings there saying that, warning, content file not found, trying another copy, and it's going to look for those files. Since this is a new array, those files don't exist. So this warning is completely normal. By doing a sync, we're basically protecting our drives. It's going to check all the data that changed in your drives, and it's going to recalculate the parity for you. So it's very important that you sync your array every day if you want to protect your server for everyday changes, or every week if you really don't add much stuff to your server and the files change very rarely. In my case, I do it every week because I don't add or remove files very often from my server, and it's perfect. It's been working perfectly fine for me. But you can schedule it to run every day. We will see that in the next part of the video where I will show you how to automate the process. So let's add some files to our drives and let's see how the calculation and how snapraid works. Now let's go ahead and add some files to our drives. I'm going to navigate to the /mnt storage. Remember, this is our mergerfs bound point. And as you can see, we have our snapraid.conf file, and I already have a couple of files here, but let's create more files. So we're just going to do vim, and then we're going to do file 2. We're going to add some text here, just so that it can have some data. It doesn't matter what it is, it's just an empty file. So whatever. We can now maybe copy that file, create a new file 3, let's say. Okay. So before we do a sync, we can do another command called snapraid-diff. Okay, basically what this command is going to do is going to scan your disks very quickly, and it's going to see if there's any changes. So if you added or removed or deleted or moved one file from one disk to another or whatever, this command will give you the output, and you'll know how many files were changed in your array. So it's just handy information if you want to use it. Now let's do a snapraid sync to sync all the new changes to the array. Snapraid sync. Okay, so that's great. This is an example of the output that you would see every time that you sync your array. So let's see what it says. So it says everything okay. Okay. Saving the state of your array to the snapraid.content file. Great. Verifying the snapraid.content files. That's perfect. So it wrote some data there. And let's see what it says here. So it says loading state from var snapraid.content. Scanning data 1 and data 2. Resizing, saving state, verifying. Okay, so it goes everything. It says syncing 100% completed in 0 seconds. So this was actually pretty fast because the files that we have in there are very small. But if you have large movie files that are like 8 gigs, 12 gig files, and like there's many changes to the disk array, this process of syncing can take up to a couple of hours depending on how many files and how big your array is. So this is why I like to automate this process so that it runs in the background once a day or once a week, and I receive an email notification telling me that the sync was successful or that the sync failed. So now that we have Snapraid up and running and set up, and we did a sync and everything is working, so now it's time to automate. For the automation part, we're going to use a script already created by someone, and this script is called snapraid-runner. We're going to clone the Git repository for this script too, and this is the command for it. I usually like to store this in the root directory of the root user. So we're here. If you do pwd is /root. We have a couple of files here already. We have our snapraid folder that we used previously to compilate, and now we have our snapraid-runner automation script. So this snapraid-runner automation script also has a configuration file that we need to configure. So let's go ahead and do that. So the first thing that we need to do is we need to rename the snapraid.conf.example to just snapraid-runner.conf. So we're going to copy that and we're going to do a move. And just leave it like that, snapraid.conf. Perfect. So if we list again, we see that now we have our snapraid.conf and our snapraid-runner.py script. So let's open the configuration file. So this is the snapraid automation configuration file. First thing that we need to do is path to the snapraid executable. Where is the executable file from snapraid? In this case, it just says executable equals snapraid, but we actually have to give it the full path. So we're going to exit out of this configuration file. And to know where snapraid was installed on your system, this will be different in any system. So if you're following up with the tutorial and you're using Rocky 9, it will be easy to find out. But if you're using Ubuntu or CentOS or Debian or any other distribution, there's a handy command that you can use to find out where the executable is actually located. This command is called which. So we're going to do that. Which, and we type the command snapraid. Okay. So it's telling us that snapraid is installed in usr local bin snapraid. So we're going to go ahead and copy that. We're going to open our configuration file again, conf, and we're going to paste that here. USR local bin snapraid. Perfect. Remember where we put our configuration file for snapraid? Yes, we put it in /etc snapraid.conf. So we need to also give that path here. /etc/snapraid.conf. Perfect. Next thing to configure is the deletion threshold. This threshold is set so if there is an amount of files that get deleted randomly, it's going to prevent the automation script from creating a sink. This is a fail-safe in the case that you lose a drive, because if you lose a drive and the automation kicks in and then it creates a new sink, basically what's going to happen is it's going to create the new parity data without the drive that failed, meaning that after that, if that happens, you won't be able to execute a recovery for this drive. So it's very important for you to set up this threshold properly. I scanned my drives in the past. There are 4 terabyte drives, and in average they have around 28 to 30,000 files each. So the threshold that I chose for my disk array and for my drives is 25,000 files. This means that if I lose a drive, the snapraid automation is going to detect that there are more than 25,000 files that are missing, and it's going to stop. Automatically, it's going to send me an email to alert me that there are more than 25,000 files missing from your drive array. And it's more likely, if this happens, it's very likely that you lost a drive. It's very important for you to set this threshold properly. Okay, so the next part is the log. So every time this automation script is going to be executed, we want to log all the output of the script so that we can have a trace if anything goes wrong. I like to store this log just in the root directory. Just it's easy to find and quick to find. So I'm going to set that up now. I'm going to go here and we're going to set this for -root snapraid.log. Perfect. Max size 5 megabytes. I don't think it's you can set this up for more, but 5 megabytes the default is pretty good. Yeah, it's going to do a log rotate, so you're always going to have the latest logs from the latest syncs. So now we have the configuration for the email. For this, I use Gmail as my SNTP provider, but if you have any other SNTP provider, then you have to set this configuration here. If you want to set it up with Gmail the same way I did, you need to create an application password. This is created on your Google account, and you're going to have a specific password that will allow this script to use the SNTP, use your Gmail account to send yourself an email. I'm going to show you how I set it up here so that you can follow the same way with Gmail. So the first configuration for here is send on success and send on error. And this is going to send an email if the sync is a success. It's going to send you an email telling you that it was successful. If the sync has errors, it's going to also send you an email telling you that there were some errors. Short true. Here you can change this if you want to have all the output, like the entire output of the sync command. You can set this to false, but it's going to be a really big email that you're going to receive. So I just leave it to short. I just really need to know if it was successful or not. And it's going to tell you how many files changed and basically the important information. So I just leave this as true. And then you just need to put your email at Gmail, and you want to send yourself an email. So from your email to your email. Host is smtp.gmail.com. The port is 465. Here I leave it TLS, I leave it false, and then SSL I leave it true. Google requires this to be able to send and receive emails. And then the user is going to be your email, and the password is going to be the password of your application. So Gmail application password. Leave a comment down below if you want me to show you how to create a Google application password for this. So now the next part is scrubbing. So scrubbing is basically a feature of snapraid that from time to time or whenever you want, it's going to read all the data and compare the data of the array with your parity data. This is kind of like a sanity check to make sure that all the data in the parity file is correct and there hasn't been any corruption. Here is disabled by default, but I usually run it from time to time, and I run it every time I sync, so every week, to make sure that the data that it's there is not corrupted and it's actually correct. If you lose a drive, you're going to actually be able to restore that information and it's not going to be corrupted information. So I set this to true. Here, I usually do 25, and what this means is a percentage of the drive array. I want to check 25% of the array, but I want to limit the scrub to only the files that are older than 10 days. This is because I don't really need to scan every single file across all the drives. That takes very, very long. I tried it once, and for my array, it took around 8 to 9 hours just to be able to read all the information from the array. So it's not really necessary, but if you really want to make sure that every single file on your array is not corrupted, then you would set this to, you will set the plan to full, and then this, you would just comment this file out this way. With this configuration, you're telling the automation script to, every time that you're going to do a sync, it's going to scan every single file and compare it to the parity data, and to make sure that the data is not corrupted. For this tutorial, I'm just going to set this to 25% of the disk array, not all older than 10 days. I think that's a very healthy setting for this. Okay, so now that we have this all set up, we're just going to save. So before we set up the automation, let's execute the script to make sure that everything is working. I set up the email, just put a dummy email. So if I execute the script right now, it's going to fail. So I'm just going to go back and change the email configuration to false so that I don't get any errors in the execution of the script. So to disable the email, you just need to comment out by putting a semicolon on all the email and SMTP configuration. And then we save. So let's execute the script and check out the output. Okay, as you can see, the script runs a diff command first. It checks if there are differences. As you can see here, it says that there's no differences because we didn't add or remove any files from the array. And in this case, it's not going to sync. It says no changes, no sync required. And then it's going to do a scrub, but since no files are older than 10 days, there's nothing to scrub. Now that our script is working, now let's automate it. To automate it, we're going to configure a cron tab. If you don't know what a cron tab is a built-in automation scheduling task tool from Linux. It's very handy and it's great. So we're basically just going to schedule the execution of this script to run every day or every week. So I'm going to open the cron configuration and we're going to set up our cron job. For that, we're going to go to /etc cron tab. Okay, so we open this file and I'm going to paste here my configuration that I have for my production server. I do it once a week. So if you want to do it once a week, this is the configuration that you need to put. So this is the configuration. Basically, this is where we're scheduling it. I'll explain how this works a little bit better if you want to do this every day. We're going to use something called a cron tab calculator. It's going to help you understand how this works. So the next part is we're going to tell it to use the root user. We're going to use Python 3 because the script is it's written in Python. We're gonna tell it what is the Python script that we want to run, and then the -c is to tell it what configuration file do we want to use when running this script. Basically, our snapraid runner configuration file. This is set up to OPT, but as you remember, our snapraid runner script is not in OPT, it's in root, so we need to change this to root. If you want to store this snapraid runner folder somewhere else, you can put it anywhere you want, but you would have to change this configuration here. Okay, so let's save the changes. Okay, we save that. And as easy as that, we configured a scheduled task that is going to run the automation script and is going to check everything on your array using snapraid, and it's going to create a sync if it needs, it's going to scrub and check for the data if it needs, and it's going to send you an email if it fails or if it's successful. Now, if you want to set up this every day, let's open our browser and we're going to look for something called cron tab calculator. Calculator. The first one is fine. So this is a handy application that will help you create your scheduled jobs. Let's put this back to normal and let's grab the current one that we have. If we open our Cron tab again, we say that it's 01. Okay, we just copy that and paste that here. And as you can see from the output of this, it says that it's going to run at 1 a.m. on Friday. So every Friday is going to run it at 1 a.m. I put it at 1 a.m. because my disk array is quite big, so sometimes it takes very long to complete. So it starts at 1 a.m. on Friday. Saturday morning, I wake up and I see an email from my automation telling me whether it was successful or if there was any errors. Now, if you want to run this every day, the only thing that you need to change is you need to change this 5 for nothing, just an asterisk. And basically what this means is it's saying that at 1, meaning that it's going to run every day at 1 a.m. And that's pretty much it. So if we go back to our configuration file, our cron configuration here, we can just come here, remove this 5, put a star, save our configuration, and now the automation is going to execute every day at 1 a.m. Congratulations, you've now learned about the power of SnapRaid and how to set it up in your home server. Thank you for watching. If you find this video useful, don't forget to leave a thumbs up and subscribe to the channel for more content like this. If you have any questions or suggestions, feel free to leave them in the comment section below, and I'll see you on the next one.